Hello, today I will be talking to you about the Charge Tapes Lab Part 2, Physics 2212 Lab 2. My name is Yubo Fu. We know that objects can acquire an excess or deficiency of a negative charge through interactions with other objects, and in this experiment we will model the excess charge on a charge tape as a line charge rather than a point charge, which we did in our previous lab. This will give us a better understanding of the charges an ordinary object can hold. Physics principles. Specifically, in this experiment, we're floating one charge tape above another, and this occurs when the F net is zero, or when the forces of electric field and gravity cancel each other out. And we've modeled this previously using a point charge, and now we're doing it using a line of charge. Experimental setup. So we created two pieces of charge tape by ripping off pieces of upper tape from base tape. So now we have two pieces of charge tape. We designate one as tape B and put it on some supports, and then we bring tape A closer and closer to tape B until tape B starts to hover, and this is when we know that the force of gravity and the force of electric field are exactly canceled out. And here is our data on the length, mass, and distance that we recorded during our experiment. This is our computational model. We are assuming that this time that these tapes are a line of point charges uh, that each have a slightly different um, x and y component, and we add all of these up to get the F net. And in this one, in this model, we're making assumptions that the charge of A or charge of tape A and charge of tape B are the same because we created them the same way, and we're no longer assuming that the tape charges are point charges, and the error resistance is not applicable because the tape is not we're not trying to accelerate the tape any. We're trying to hold it in this equilibrium state where the F net is zero. Coding. I filled out the starter program and gave the program the proper equations and data values, and I set n equals to 2000, so there's 2000 point charges being simulated for a slightly more accurate approximation. To use the program, you just set the constants equal to the experimental values that you obtain, and then just experiment with different values for the charge until you find one that will result in a magnitude of electric force being equal to the magnitude of the gravitational force. The code itself is fairly simple. It is mainly a sum function that calculates the components of each point charge and then adds them all up. So the component vectors are shown in green because there's 2000 charges. They merge into one really big fan shape, and the resultant E force vector, E field force vector is shown in white. Results. We determined the charges on the tapes to be approximately 2.624 times 10 to the negative 8 coulombs, and this makes sense because it's pulling the charge of one electron at every electron on the tape. And we did some calculations for how many atoms there are on the tape, and then we also know that an electron's charge is 1.6 times 10 to the negative 19 coulombs, so we can know how many electrons were added. And now that we have the numbers of how many atoms there are and how many electrons we added, we know that one electron was added per every 1.2 times 10 to the 12 atoms in the tape. Lab questions. What if we modeled each of our tapes as a single point charge like in the previous lab? Well, we got 1.307 times 10 to the negative 8 coulombs for point charge approximation, and now we have 2.62 times 10 to the negative 8 coulombs for our line charge approximation. And we can see it's about twice previous estimate. And why is there a difference and why does it matter? It's because the point charge approximation ignores horizontal components, so there is less charge being accounted for, and therefore less accurate. Conclusion. In this lab, we updated our computational model for the charge tapes lab using a line charge model, which is more accurate. And we got a new calculated charge on the tape being 2.624 times 10 to the negative 8 coulombs, Some sources of error and uncertainty were that we couldn't really know how much charge was on the tapes. There was no way to know that they were same, and also what if we handled them on accident just because we have to move the tapes around to perform an experiment, and also the electromagnetic fields could have also interfered with our measurements and the behaviors of the tape.